welcome to MLOps Zoomcamp session 4 about deployment, and in this video we'll talk about deploying our model as a web service. And in our first model we created this notebook, and we spent a lot of time explaining what's wrong in this notebook, but at the end of this notebook we created a pickle file. Right, we put our dictionary vectorizer and linear regression there, and we saved it as a pickle file. So now we can take this pickle file and deploy this as a web application. So this is what we will do in this model. So here we will just take the pickle file and put this in a Flask application. So we will not talk about MLflow, model registries, and so on. We will just focus on creating a web service, but in the next video I will show you how to connect the model registry from MLflow with our web application. So let's start. The plan for this video is to actually follow everything we did in ML Zoomcamp. So in the ML machine learning Zoomcamp we had a model about deployment, and in this module, in this section, we took a pickle file and deployed it as a web service. So exactly what we are going to do right now. So if you haven't seen this, and if you don't know much about Flask, virtual environments, Docker, I highly recommend to check it out, because I will not spend a lot of time now explaining some of the concepts. So if you don't know what Flask is, if you don't know what virtual environment is, if you don't know what Docker is, please check the video, please check that module, and we will do something similar here in this video. So in particular, we will create a virtual environment, we will use Pipenv for that, and then we will put our model in a script, then we will put the script into a Flask application, and then finally we will package everything in Docker. That's the plan. I already have a model here. So I created a folder in the 04 deployment folder. I created another folder, web service. This is where we will create a project right now. So the first thing we need to do is we need to find out the exact version of scikit-learn that we use for creating this pickle file. We want to make sure it's the exactly same version, because if we install a different version of scikit-learn and we try to unpickle this file, it might not work, because maybe there is a new functionality and so on. So we need to make sure that it's the same version. And for that, we can do pip freeze. So pip freeze will show all the libraries that we currently have installed. And then from them, we are only interested in scikit-learn. So I'll just do grep scikit-learn. And we see that we use scikit-learn of version 1.0.2. So this is the version we need to install. So I'll need to do pipenv install and this one. Then we will also need Flask. I don't think we need to use anything else. I would just hit enter right now, but I will not do this, because I am on Ubuntu 22.04, which has a new version of Python. It has Python 3.10. which is a relatively new one. I don't know how well scikit-learn and other libraries we use for this course work on this version of Python. So I would rather stick to Python 3.9 to be on the safe side. And for that, I want to specify that I want to use 3.9 this way. I can either just say that I want to use Python 3.9, or I can specify the path to exact Python executable I want to use. But Pipenv should be smart enough to figure out that there is a Python 3.9 in Anaconda. Yeah, it uses this one, right? And it uses the version of Python we have is 3.9.7. And now it's installed in scikit-learn, and it will install Flask, and it will create a virtual environment for us. And this virtual environment will be isolated from the base Python we have, and it will contain only the libraries we need, only the libraries that this specific application needs. Now to enter it, we do pipenv shell, and now we enter this environment, and you see our command prompt becomes pretty long, right? So probably pipenv or virtual environment and conda do not play well together. That's why, like, not only we have these two things, but this thing is also pretty long. So I'll just do this thing here. So I will change the prompt. And now, yeah, it's shorter. Okay, we created this pip file. Maybe let me take a look at this pip file. Yeah, so we have scikit-learn here. We fixed, we pinned the exact version we need. Then we have Flask, and we have Python 3.9 for this. And then here we have in the log file, we have the exact versions of the libraries. So for example, here In the pip file, we didn't specify the version, but in pip file lock, we also pin the version, right? And when you take this pip file lock and you do pipenv install, it will install the same version of Flask as I have. So it's pretty convenient. Now let me just create a file. I'll call it, I don't know, predict.py, and this file will contain the code for loading the model and for scoring the requests, and basically we will have our web service here. So what it needs to do, it needs to load this file, linrec bin. Now let's do this. So it's very similar to what we had here. So let me just copy it. And for this, I will need to have an import pickle. But instead of open it for writing, we need to open it for reading. And then I will change this to fin. So fout is file for outputting and fin for reading. And yeah, instead of dump, we use load. And this will load from this file, and this thing is returned. So we get dictionary vectorizer and we get a model. Let me just replay it as rename it as model. So that should work. That should load the model. And now maybe let's create a function. I'll call it predict. It will take in features and it will turn these features into a matrix using dictionary vectorizer. Transform features, right? We'll get our x, and then we can use model predict, and we put our x there, and we get our predictions, right? And then we can just return predictions. So that's roughly the code of taking the model and using this. Now let's test that everything works. For that, I will create a file that I'll call test.py. And what we will do here is I'll just simply import. So right now I'm not sending any web requests, so I'm just importing this Python file as a module, and then I will invoke predict to test that things work. Predict, and here we need to pass our write, and this will be our prediction, and then I will simply print it, the prediction. So now when it comes to write, we actually as the information we have about the write, we have a bunch of things. I don't remember all of them, but we only use 3 things for our model. We use pickup location ID, drop off location ID, pickup location ID, drop off location ID. Actually, I'll use quotes here, so then I can also use this as a JSON object if I need later. And then we also have trip distance. So this is our information about the write. Yeah, we just use these 3 features. We don't use anything else here. Now, of course, we could use the time when the write starts, date time. We can create a lot of features from that, but this model uses only these 3 features. I don't remember any IDs. I'm just making this up. So let's say pickup location ID is 10, drop off location ID is 50, and trip distance is, I don't know, 50 miles, something like this. Maybe 40 miles. But this is actually not something we can just put to predict, because actually we do a bit of feature engineering here. We create a new feature, which is a combination between pickup location ID and drop off location ID. And it's very important that we follow exactly the same approach in our model serving code. Right? So here I will create another function. I'll call it prepare features maybe. So then it gets the write and outputs features. There are many different ways of writing this code here for prepare features. The way I will do this is I'll just create a dictionary, and then this dictionary will contain features, something that we will put in this transform, right? So first feature that we will have, it will be our PUDO feature, which is then a feature in an engineered feature, something that we create as a concatenation of 2 features. So I'll use it like that, because I think these are integers, right? Yeah, so this is an integer and this is an integer, and in Python it's not easy to just do write. Let me just copy it from here. So if I can, of course, do something like this, but it will not work. Actually, drop off location ID. Python will complain that you cannot concatenate strings and integers. That's why we will use this approach. and then it doesn't care if it's an integer or a string, it will turn everything into a string. Then another feature that we have is trip distance, right? So here we just leave it, we just take it as is. We don't do any feature engineering here. We don't transform the data, and return features. Yeah, I think that's all, right? So the main thing we do here is this one, and then it will return a new object, new dictionary that we can use here. Features, predict, prepare features, and then we will pass the right there, and then the features will pass to the predict function. The predict function will output the prediction, and we will just print it. So let me test it. So I'll just do python test.py, and yeah, of course it doesn't work because we don't have the models folder. We have it here in this directory. So let me try one more time, and it works. We see that it outputs a list. We don't need a list, we just need a single value. And that's why here I will just take the first value. Good, yeah. So this is the prediction for this particular object. For this particular write, we predict that the duration will be 26 minutes. So far so good. Now let us turn this thing into a Flask application. We have almost everything we need, right? We have this predict function, we have prepare features. We just need to create another function that will be like a wrapper around these two, that will take requests, web requests, HTTP requests, and then score the write that it gets in the request, and then return the prediction. So I'll call it predict endpoint maybe. And in Flask, usually they don't get any parameter, so we need to get this parameter from Flask. Actually, I need to add an import from Flask, import Flask, and then we need also request and JSONify. So we need three things. You will see how we exactly use these things. We will start with requests. So request gives us a way to get data from the request. So the request, the body of the request will contain the information about the write. So this is how we get it. So this will be our write. And then we pass the write to prepare features. Basically, I can just copy that, put it here. So we do not need predict, of course. That's our prediction, and the result will be a dictionary with duration, and we just return this thing, right? And then at the end we return this, and we want to return a JSON object. That's why we call this JSONify thing, where we turn the dictionary into a JSON object. Yeah, now we need to start to create a Flask application. So it will look something like that, Flask, and then the name, duration, prediction. And here we need to add a decorator. So this decorator will add some extra functionality to this function. So it will actually turn our function into HTTP endpoint, and we can start sending requests to this endpoint and get responses. I don't remember the syntax, so I will quickly look it up, because this is something we covered in MLOps Zoomcamp. So I will just go to the code, open the predict.py file, and copy this thing. So this is what I need. So this will turn our predict endpoint function into an endpoint. We're almost done. We just need one last step here, is this one. So we need to actually run this Flask application. And this is what we do here. So this is our app, Flask application, and we run it on localhost on port 9696. Yeah, let's test it. We'll just do python predict.py, and it is running. So now we can try to send a request. Now for that, I will modify the test.py file. So here, instead of importing predict, I will import requests, which is a library for sending requests. And this library has a method called post, a function called post, that we can use for sending post requests. And here we need to specify the URL, the endpoint to which we want to send the request, and then we want to send in the body of this request, we want to send the information about the write as JSON file. That would be our response. And now we can just print the body of the response as JSON, something like this, right? And then of course we need the URL, and URL is, we can take it from here, or you can also write localhost here, doesn't matter. And I think that should work. Yeah, you see, we actually, like every time I save something, the Flask sees that there is a change in this file, and then it reloads it. So now I will go to another tab and I will just run this test. And something is wrong. So let us see. I think it says 404. Yeah, right, because we didn't specify the endpoint here, the name, predict. So we need to send the request to predict. And now we get the prediction. So everything works. I'm actually wondering why. Okay, because I actually, to be honest, I was expecting an error here. So I thought I would need to wrap this in a float, because this one is a NumPy object. Okay, but apparently it works anyways. That's good. So now we actually put our model in a Flask application, and we can interact with this application. We can send a write, information about our write, and get the prediction for this write. And yeah, one more thing is when we start our Flask application, we see this warning. So it says, this is a development server, do not use it in production deployment. Use a production VSGI server instead. Yeah, we need to do something with this. And to fix this warning, we actually need to do what it says, what it tells us to do. We need to use a production VSGI server instead. And one of such production servers is gunicorn. So we just need to install it, gunicorn, and we can use it instead of Flask. So Flask, the web service we have here, it's only used for development purposes when you run things locally. But you need to have a proper VSGI server if you need to actually put this into production. And now we can use gunicorn for starting this. So I don't remember the exact syntax. Let me quickly check it. So check it here. So it's gunicorn, then bind. So we say on which address this thing runs, and then we need to say that the application lives in the predict.py file, this one, right? And this is the thing we're interested in, the app. So we say go to the predict module, Python module, and look for variable with name app. And this starts our application. So now we run the same application, but instead of Flask, we use gunicorn. And now we can test that this thing still works. Yeah, good, it works. Another thing is, you see that I actually use base Python here for sending the requests. Here, this thing, requests, is a library, which is an external library. So if I do pipenv shell now and try to do Python test.py, then it says no module named request. So we actually, if we want to have a self-contained environment that has everything we need, we also need to install request module here. But the thing is, we need requests only for tests. We don't need this for the production, for serving it in production, because in our predict.py, we don't have any requests here. We can install the request library as a development dependency. So only when we develop, we will have this dependency, but when we deploy this to production, this dependency will not be installed. And we can do this by using pipenv install --dev, and then the name of the package, requests. Now it will install this library as a dev dependency. We will have this on our computer, on our for developers, for people who work on this model, but when we deploy it, it will not be there. And now if I try to run Python test, now it works. Okay, so we, I think, covered most of the content that we planned for this video. There is just one last thing, is packaging the app to a Docker container. Let us do that. So I'll create a Docker file for that. And I just want to quickly check what kind of Python we used. So for us, we used this Python. I'm just wondering if I do Python v. Yeah, it's the same version of Python here. So I want to make sure that we use the same version of Python. At least it should be Python 3.9. So maybe the minor version is not that important. But yeah, let's make sure that we actually also use the same minor version. So when we do in the Docker, now we need to get the base image, which we will use for creating an image for our service. And this image better be, better contain the same Python that we have for our development. And yeah, so we can just specify it this way, and then it will contain the Python we need. It is a Debian Linux here, so we can do apt-get install and so on, the usual things we do on Ubuntu when we need to install dependencies. I usually use the -slim version. So here -slim means that we want to take the same image but reduced in size, and you can see the possible options if you just do Python Docker image. So you go to, you see like the first result for me is Docker Hub. You open it and you can see all the available tags here, right? This tags. So we need 3.9, the latest one is 3.913, and this slim one. Now we can actually say we just care, we don't care about the minor version. We want the major version should be the one we want, but the minor version we don't care. Yeah, there are many different, like here Alpine, this is different kind of Linux, but yeah, I usually go with Slim. So let's go with Slim as well. And in this Docker file, we need to install a couple of things. So first thing I usually do is pip install update pip. It's not, sometimes it's helpful, not always required, but I just want to make sure I have the latest pip, because for some packages, for example, XGBoost, it's important that the version of pip we have here is the latest one, because sometimes these repos, they have a slightly outdated version of pip, which cannot correctly build XGBoost package, for example. Then we also need to install Pipenv, because this is how we manage dependencies. And now we need to copy our pip file and pip file log and to our Docker image and install the dependencies from this pipenv, pip file log. So we copy them to the current directory. So that's why we need to say that this is a directory by adding a slash at the end. So it will, whatever the current directory is, it will copy the files there. Actually, speaking of working directories of the current directories, we need to specify the directory where we want to copy the file. So what actually this dot means, right? And this dot, I want the current directory to be /up directory. So we will go to this /up directory and copy the files there. So now we can do pipenv install, and it will take all the dependencies from here and install. But here, actually, if we just do that, it will install, it will create a virtual environment. But since we are inside Docker, we are already isolated from the rest of the system. So we don't need to create yet another layer of isolation, like we don't need a virtual environment here. So we can skip the step of creating the virtual environment and install directly to the main Python, to the system Python, all these dependencies. And for that, we just do system -- system, and then it will install the dependencies to the system Python. And then we can also do deploy. I don't remember what this -- deploy mean. I just remember that we need to include both system and deploy. I think deploy means that let's use pip file log. I am not super certain. I just need to know that we need to use these two things. You can look it up. Pipenv has quite a good documentation. Okay, this step installs all our dependencies, and then the next thing we need to do is copy our model and our predict.py. So I'll start with predict.py and then model, and then we again copy them to the current directory, and then finally entry point. So we need to, when we do docker run, we need to tell Docker what exactly it should run, and what we want it to run is this thing. So we want it to run gunicorn. By the way, I'll stop it also here. And here we need to put every token or word of this command in quotes. But I don't think we need to change anything else here. So yeah, we want to run it on localhost. The port is 9696, and the app lives in predict.py, and then the name of the variable here is app. Yeah, one more thing is we need to expose the port 9696. So this way we tell that in this container, the port 9696 should be open. So it will listen for the request on this port. So let's open it, and then we will be able to send the request there. Now let's build it. So for that, I have a couple of commands here. So the first command will use this Docker file to build an image, and it will assign a tag, write duration prediction service to this, and v1 tag. So this is the image name, and this is the tag. So let us build it. And now, yeah, it's getting this specific version of Python. It's pulling the base image and then adds extra things on top of this base image. So now it's adding, it's loading Pipenv, and now it will install things from Pipenv. I don't know why it's red. Looks strange, but I don't see any errors. Maybe it just likes using red. I don't know. So it's installing dependencies, and yeah, it's ready. Now we can test it. For testing it, I have another command. So here -it means that we want to run it in interactive mode. So then we can exit this by pressing Ctrl+C. Then --rm means that we should remove the image after we are done with this. And this -p means that we need to map port 9696 on the host machine to the port 9696 on the container. So then we can use localhost for sending the requests. And this is actually the name of the image we want to test. Okay, yeah, it's running. And we can use now the same code for testing it. And now instead of going to gunicorn or our local Flask, it goes to the model deployed packaged in a Docker container. Okay, that's pretty much it what I wanted to cover in this video. So now when we have a Docker container, we can do anything we want with this Docker container. So there are many things we can do. So we can deploy it anywhere where Docker is supported. So for example, so I'm just trying to find, yeah, I want to find it here. Yeah, this one. So in MLOps Zoomcamp, actually in this module 5, what we did with the Docker container is we took it and we used Elastic Beanstalk, AWS Elastic Beanstalk for deploying the Docker container. So you can check it out. Yeah, I don't think you will need to change anything. You can just basically follow this unit and you will deploy this service we just created to Elastic Beanstalk. That's one option. You can also deploy it to, for example, Kubernetes. We also cover Kubernetes in the MLOps Zoomcamp. And then here, for example, you can look at modules 5 and 6. Actually, module 6 is about taking a simple Flask application and deploying it to Kubernetes. So if you're interested in that, check these two videos, and you will know what to do with this Docker container. I will not spend time here talking about that. There are many different options, but the important thing here is that you have a Docker container, and that's enough to serve your model somewhere. But that's not the end of the story, right? So here we took the model here, but in module 2 of MLOps Zoomcamp, we talked about model registry. In model registry, we keep the models, right? So we can store the model and then we can retrieve a model from there. So it would be nice, instead of sending files over email to a deployment engineer asking, hey, we have this new version of the model, let's deploy it. It would be nice to talk to a central server, a model registry, and get the model from there. Right? And this is what we will do in the next video. In the next video, we will see how to connect the app we just wrote, the Flask application, to a model registry from MLflow. So see you soon.